An interacting galaxy pair is commemorating the second science anniversary of NASA's James Webb Space Telescope, which continues to conduct continuous observations, including highly detailed data known as images and spectra. These operations have led to a parade of discoveries by astronomers worldwide. Since President Biden and Vice President Harris unveiled the first image from the James Webb Space Telescope 2 years ago, Webb has continued to unlock the mysteries of the universe, said NASA Administrator Bill Nelson. With extraordinary images from the corners of the universe reaching nearly back to the beginning of time, Webb's capabilities shine a new light on our celestial surroundings, inspiring the next generation of scientists, astronomers, and explorers. Mark Clampin, director of the Astrophysics Division at NASA headquarters in Washington, said, "In just 2 years, Webb has transformed our view of the universe, enabling first-class science that drove NASA to realize this mission. Webb is providing insights into long-standing mysteries about the early universe and pioneering a new era in the study of distant worlds, while returning inspiring images that pose exciting new questions. Exploring every aspect of the universe has never been more possible." Webb's expertise in capturing infrared light, which our eyes cannot detect, shows that these galaxies, collectively known as ARP-142, are locked in a slow cosmic dance. Webb's observations combine near and mid-infrared light from Webb's NIRCam, near-infrared camera, and MIRI, mid-infrared instrument, clearly showing them merging in a mix of stars and gas, represented in blue haze, as a result of their interaction. This ongoing interaction was set in motion 25 to 75 million years ago, when the penguin, individually cataloged as NGC 2936, and the egg, NGC 2937, completed their first pass. They will continue to wobble and sway through several more loops before merging into a single galaxy hundreds of millions of years from now. The penguin was a spiral galaxy before their initial approach. Today, its galactic center glows like an eye. Its unraveled arms now shape a beak, head, spine, and outstretched tail. Like all spiral galaxies, the penguin remains rich in gas and dust. The galaxy's dance gravitationally pulls on the penguin's thinner gas and dust lanes, causing them to collide and form stars. Look for these areas in 2 places: the fish-like portions of its beak and the feathers of its tail. These new stars are surrounded by a smoky material containing carbon-rich molecules known as polycyclic aromatic hydrocarbons, which Webb excels at detecting. Dust, seen as fainter, deeper orange arcs, also trails from the beak to the tail feathers. In contrast, the egg's compact shape remains largely unchanged. As an elliptical galaxy, it is filled with aging stars and has much less gas and dust to draw on for new star formation. If both were spiral galaxies, each would end the first twist with new star formation and tidal tails of swirling filaments. Another reason for the egg's undisturbed appearance: these galaxies are approximately the same mass or weight, so the elliptical body, which appears smaller, hasn't been consumed or distorted by the penguin. The penguin and egg are estimated to be about 100,000 light-years apart, which is quite close astronomically. For context, the Milky Way galaxy and our nearest neighbor, the Andromeda galaxy, are about 2.5 million light-years apart. They too will interact, but not for about 4 billion years. To see a galaxy not participating in this party, look to the upper right. This edge-on galaxy, cataloged as PGC 1237172, is 100 million light-years closer to Earth. It is also quite young and filled with new blue stars. Want another party trick? Switch to Webb's mid-infrared image alone, and watch PGC 1237172 nearly disappear. Mid-infrared light mostly captures cooler, older stars and immense amounts of dust. Since the galaxy's star population is very young, it disappears in mid-infrared light. Also, take a moment to scan the background. Webb's image is teeming with distant galaxies. Some have spiral and oval shapes like those extending along the penguin's tail feathers, while others are scattered as shapeless spots. This is a testament to the sensitivity and resolution of the telescope's infrared instruments. Compare Webb's view with the 2018 observation, combining infrared light from NASA's now-retired Spitzer Space Telescope and near-infrared and visible light from NASA's Hubble Space Telescope. Even though these observations only took a few hours, Webb revealed far more distant, redder, and dustier galaxies than previous telescopes could, giving another reason to expect Webb to continue broadening our understanding of everything in the universe.